So this is a balancing equation question, and this is actually from our textbook on page 170, question 5.7a, and this is where we have chlorine, and we are mixing that with sodium bromide to get sodium chloride plus bromine. And so when we're starting balancing an equation, what I like to do is I just like to count what I have of each element. So I'll start left to right. So I have 2 of chlorine, I have 1 of sodium, and I have 1 of bromine. And on my other side, again, I want to try and keep things as equal as possible. So I'm going to do chlorine again, even though it's not the first element that we see. So I have 1 chlorine, 1 sodium, and 2 bromide. And this is a question that we've done in class. So the first thing that we notice, we should be looking at, is what is out of balance. So we've got bromine that's out of balance, and we also have our chlorine that's out of balance. So what we're first going to do is we're going to address, it really doesn't matter which one you address, because at the end of the day we need this to balance out. So what I'm going to do is I am going to first deal with my chlorine, but you don't have to do that. So in order, I have 2 chlorines on this side and I only have 1 on my right side. And so when I look at the equation, I only have chlorine attached to sodium on my right side, so I can only add a 2 there. Okay, so remember that we're not just, it's not really adding, we're really multiplying that 1 chlorine by 2 to get 2, so it balances the other side. So now I can say that I have 2 chlorine, so my chlorine's now balanced, but that 2, as we've talked about in class, refers to a lot of different things, and in particular in this example when we're balancing equations, it also represents now that we have 2 sodium elements. So I also have to change the sodium number on my right side from 1 to 2. So now we still have our bromine unbalanced, but now the sodium is unbalanced. So we have 2 sodium elements on our right side, but we only have 1 on the left. So what I'm going to do is I'm going to add a 2 to that sodium bromide on the left side of the equation, so that now the sodium's balanced out and they are good to go. Now, fortunately, as I've just said with the sodium chloride, with that principle of the 2 representing not only chlorine but sodium, that also implies as well. So we have 2 sodium, but we also have 2 bromides. So actually now what we have done is balance this equation, because we have 2 chlorine on each side, 2 sodium on each side, and 2 bromine on each side. So when we're balancing equations, it's really important to just start with the smaller numbers first and work your way up. If we have to increase from 2 to 3, we will do that in the next step, but don't just necessarily assume that's what we have to do. So this is another example that we have with, this is question H from 5.7. And so there's a lot of different things going on here, but we're going to do the exact same thing that we did with the other example. Let's start by counting what we have of each thing, because even though sometimes equations look long, we might not need to do that much to it. So we have 1 calcium element on our left side. We have 1 carbon. We have 3 oxygens, we have 1 hydrogen, and 1 chlorine atom. And I'm going to do the exact same thing to the right side. So I have 1 calcium atom, I have 1 carbon, I have 3 oxygens, so 1 there and 2 there, that gives us the 3. I have 2 hydrogens, and I have 2 chlorine. Okay, so we have 2 things that are out of order. It both deals with the hydrogen and the chlorine. So this actually can work out really well for us, because notice here that both on our right side we have 2 of each hydrogen and chlorine, and only 1 of each on our left side. And it just so happens in this equation, hydrogen and chlorine are together as hydrogen chloride. So this is actually a really simple equation to balance, because the only things that are out of proportion is the hydrogen and chlorine. So by simply adding a 2 on the left side, we have now increased both the hydrogen and the chlorine to balance out, because that 2, as I've said before, not only applies to the hydrogen, but it also applies to the chlorine. That we have 2 hydrogen chloride compounds or compounds here, and what that means is that in each compound they have, you know, one hydrogen, one chlorine, which is fine, but in total, based on the two, we have 2 hydrogen and 2 chlorine. So there's just another example of balancing chemical equations. So let's take a look at a little bit more complicated question. So we have KClO3, and that will dissociate to become KClO4 plus KCl. Okay, so what we have here, we're going to do exactly the same thing. We're going to count every element that we have on each side. So I have 1 potassium on this side, I have 1 chlorine, and I have 3 oxygens. On this side, we've got 2 potassium, I have 2 chlorine, okay, and I have 4 oxygen. So it's a little bit more of a difficult question only because everything is completely out of balance. So the one thing that we can do and look at here is clearly the potassium and the chlorines are out of balance, and the only thing that we can do, is add potassium and chloride to the left side of the reaction, because we already have as our products 2 potassium and 2 chlorine. So the first thing that I'm going to do is I'll add the 2 to our KClO3 compound, and so that'll immediately alleviate the problem of our potassium and chlorine. But now I've got the issue of actually having 6 oxygen on my left side and only 4 oxygen on my left. And so that poses a huge problem, because now what we have to do is figure out, well, how do we balance the oxygen, giving 6 on one side, 4 on the other. Now, when we look at this equation now, typically what we can do when we see we have our oxygens are out of balance and that everything else is relatively equal, like, I mean, we solved the 1 to 2 problem, what we can actually do is just switch those numbers, okay? The reason why we can switch the numbers, the 4 and the 3, essentially, so let me go ahead and do that. So I'm going to erase the 2, okay? And what I'm going to do is I'm going to replace that 2 with a 4, okay? And so this is what I mean by replacing the numbers, is I'm using the 4 given to us on the right side, our product side of the equation, which we have 4 oxygen, and now I'm saying, well, we have 4 moles of KClO3, or 4 element compounds of this. And so that 3 from the KClO3 will go in front of the KClO4. And so with this in mind, now we're going to add everything back up. So we now have 4 potassium, we have 4 chlorine, and we have 12 oxygens, okay, because we have to multiply 4 by 3 to get the 12. On the other side, if we just erase those values here, okay, I have 4 potassium, okay, because I've got the 3 here plus the 1 there. I have 4 chlorine, 3 there, 3 here plus the 1 over there. And again, 3 times 4 gives us 12 oxygen. So everything balances out. So it is good to start, again, like I said in our previous examples, small. Start with the ones that it's easy to just put to double and do it that way. But when we see numbers of like 3 and 4, okay, typically what we want to do when we're balancing equations is find a common factor between the two. And unfortunately, the only common factor we have here between 3 and 4 is 12. 3 times 4 equaling 12. If we had KClO2, the common factor would be 4. Okay, because 2 can go into 4 evenly. So really, when we're talking about balancing equations, it's really just a matter of understanding our multiplication tables and adding and subtracting rules. So I hope this helps. Please let me know if you need any more assistance.